Good morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. Today's my topic is basic concepts in sampling and quantization. So before going to this sampling and quantization topic, so these are belongs to digital image fundamentals. So what are the digital image fundamentals? So elements of visual perception, image sensing and acquisition, sampling and quantization, relationship between pixels, signal, spatial gray level resolutions. So these are the 5 types of digital image fundamentals. So in the previous we discussed elements of visual perception, image sensing and acquisition. Now we are going for the sampling and quantization. So what is the sampling and quantization? But before going to this one, these are all digital image fundamentals. Okay, without knowledge of these fundamentals, we can't understand the sampling and quantization. So these are all belongs to image fundamentals. So what is sampling and quantization? That is a basic concepts in sampling and quantization. So the number of quantization levels should be high enough for human perception of finite shading details in the image. So the occurrence of false quantum is the main problem in image which has been quantized with insufficient brightness levels. So there are 2 types of methods are used in image processing, namely analog image processing, digital image processing. So what are the problems we are facing with the digital image processing? So that one. And so suppose we have the images there. So what are the quantization levels should be enough for the human perceptions in the shading details of the image. So the occurrence of the fault counter is the main problem in image which has been quantized with insufficient brightness levels. So what are the brightness levels are there? Those are insufficient. So with the help of sampling and quantization, we are going for the reducing the insufficient brightness levels and reducing the noises. So what are the types of methods used for image processing? Analog image processing, digital image processing. So suppose example, one person is there. Okay, this I am calling as it is a analog. So with the sensor or photo camera, I am capturing this person. So with the sensor or human, I am capturing this person. So what is the output? That is the image of human. So when I am applying the sensor or photo camera is a input, and I am capturing this human face or body, that is a human analog. So this human I am calling as an analog. So after getting the image, that is the image of human, that is called digital image. So the input is a analog and output is a digital. So input is a analog and output is a digital. So what is the analog? The human, the physical person, what are the physical devices or items or persons are there? I'm taking as calling as those are the analog. After capturing this image, that is a digital. So analog to digital conversion. So analog image processing can be used for hard copies like printouts and photographs. So when I'm going for the printouts, so after this digital image is there now, so I'm getting the printout. So this printout is a hard copy. So that I am calling as an analog image. So after getting the digital image, I am taking the printout of this one, that is called the hard copy. This hard copy I am calling as an analog image. So the image analysis use various fundamentals of interpretation while using these visual techniques. So what are the visual techniques we are applying here? So the digital image processing techniques help in manipulation of the digital images by using computers. So without computers we can't do anything, analog to digital or digital to analog like this. So digital image processing technique help in manipulation of the digital images by using computers. So I am getting the printout. How I am getting the printout? I am using computer. So digital image is there. Yes, it is the digital image there. With the help of computer only, I am capturing that one. I will be see the image in the computer only. So I have to take the hard copy with the help of computer only. So like this, and there are three general phases at all types of data have to be under while using digital techniques are pre-processing, enhancement, and display information extraction. So these are the three general phases of the types of data have to undergo while using digital techniques or pre-processing of enhancement, display, and information extraction. So, in order to become suitable for digital processing, an image function, an f of x comma y, must be digitized both spatially and in amplitude. Suppose one image is there. This image I am taking as x and y axis. So, what is the function of the image? F of x comma y. So, it is the image. What are the coordinates of the images? I am taking as a f of x comma y. So it is become to suitable digital processing. The image function f of x comma y must be digitized both spatially and in amplitude. So this x comma y, f of x comma y must be digitized. When I am taking this one digitized, when I am preferring the function is f of x comma y in the digitized form. So typically, a frame grabber or a digitizer is used to sample and quantize the analog video signals. And in order to create an image which is digital, we need to convert continuous data into a digital form. How to create? To create an image which is in digital, we need to convert continuous data into digital form. Suppose one person, I have to capture this one, I have to convert to the digital image. So how it is possible? So when I want to create the image, digital image, so I need a digital image from the analog. We need to convert continuous data into the digital form. The continuous data is converting to the digital form. So it is a continuous data converting to the digital like this. So it is a continuous and it is a digital. So the sampling rate determines the spatial resolution of the digitized image, while the quantization level determines the number of gray levels in the digitized image. The magnitude of the sampled image is expressed as a digital value in image processing. The transition between continuous values of the image function and its digital equivalent is called quantization. So, what are the sampling and quantizations are there? The sampling rate determines the spatial resolution of the digital image, while the quantization levels determines the number of gray levels in the digitized image. Suppose I am taking one image. This image has a 256 into 256 size. Okay, so I am taking as a 256 into 256. So each one. So each one has a resolutions. So what are the resolutions? Suppose it has some 25, here some 256, here 120, here 86. So every pixel, what are the values are there? Those values are I'm taking as a gray levels. So in the digitized image, while quantization levels determines the number of gray levels in the digitized image. So how many gray levels are there? Suppose I'm taking 256 into 256. Each cell has a how many gray levels are there? Each pixel, how many gray levels are there? So that are the total 256 into 256. Suppose every pixel I am taking the intensity values. So those are the 256 into 256 gray levels are there in the digital image. And a magnitude of the sampled image is expressed as a digital value in the image processing. So the transition between continuous values of the image function and its digital equivalent is called quantization. So what is a quantization? Sampling means number of, suppose these intensity values I am converting to the samples. So what is the quantization? So the quantization is the transition between continuous values of the image function in the digital equivalent is called quantization. It is the input. It is a continuous signals. I am converting to the digital form. So discrete form means 1, 0, 1, 0, so on. So in the form of binary, 1, 0, 1, 0, so on are there. So continuous signals are converting to the digital form. Okay, that is a discrete form. So binary, it converting to the binary. So that is called sampling and quantization. So sampling is the process of converting a signal, example a function of continuous time or space. Suppose it is a continuous signal. So it is a process of converting a signal that is called a continuous signal into a numeric sequence, a function of discrete time or space. The process is also called analog to digital conversion or simply digitization. So this process means continuous signals are converting to the discrete signal. What is this process? This process is called analog to digital conversion. Why? Because it is a analog signal. When I am converting to this binary, that is called digital signals. Digital signals means in the form of binaries. So it is called ADC. So it is reverse order. Suppose I am taking digital to analog. So digital to analog. Continuous or discrete signals are converting to the continuous signals. That is a DAC. So the process is called analog to digital conversion, or simply it is called digitization, since an analog image is continuous not just in its coordinates x-axis but also in its amplitude y-axis. So what is the x-axis here? Continuous signals are x-axis and the amplitude is a y-axis. So the part of this deals with the digitization of the coordinates is known as sampling. So x-axis and y-axis. So amplitude. What is the amplitude? It is the amplitude. I'm taking it y-axis. So f of x comma y, analog to image continuous not in just the coordinates of x-axis but also in the amplitude of y-axis. So the part of this deals with the digitization of the coordinates is known as sampling. In the digitization, sampling is done on independent variable. In case of equation y equal to sine of x, it is done by x variable. So I am forming with the y equal to sine of x. Suppose what is the y? Amplitude equal to sine of x. So sine of x means continuous sine signal, sinusoidal signal. So what is the amplitude? This amplitude I am taking as a y and it is in the x-axis like this. So quantization is opposite to the sampling because it is done on y-axis while sampling is done on x-axis. So in the x-axis I am taking as a sampling and y-axis I am taking as a quantization. So the quantization is a process of transforming a real valued sampled image to one taking only a finite number of distinct values. So sampling I am tackling already in the continuous form. So it is a sampling process. Continuous signals are converting to the discrete, that is a sampling. But here the process is called the analog to digital conversion. But here the quantization is a process of transforming a real valued sampled image to one taking only a finite number of distinct values. So under the quantization process, the amplitude values of the image are digitized. So what are the amplitude values are there? Suppose I am taking one signal. What are the amplitude values? So under the quantization process, the amplitude values of the image are digitized. In simple words, when you are quantization of the image, you are actually dividing a signal into a quanta or partitions. So quantization means we are dividing into signals into a quanta or partitions. That is a quantization. How we are taking when you are quantization images, you are actually from the samples are converting to the quantization or partitions. So input, So input is a analog image, and I'm taking as a, this analog image is a continuous signal. Sampling, I'm performing sampling, means number of samples. In the quantization, what I'm taking, partitions. So after the output means digital image in the form of binary. So what is a basic introduction of the sampling and quantization? A digital signal is superior to an analog signal because it is more robust to noise and can easily be observed, corrected and amplitude. So for this reason, the tendency today is to change an analog signal into the digital data. So what is the introduction for this one? A digital signal is a superior to the analog signal. Why? Because in the digital signal, I have to reduce the noise. What are the advantages from the digital? In the digital signal, reduce noise, convert to any of the image. Okay. So suppose I have the image in the form of digital. What are the advantages? I am reducing the noise. I am converting any type of the image, and also I am reducing the size. That is called compression. That is called compression. Okay, and restoration of that one. So like this, a digital signal is a superior to an analog signal because it is more robust to noise and can easily be covered, corrected and amplitude. For this reason, tendency today is the change in analog signal into the digital signal. That is the reason I am converting from analog to the digital. So an analog signal, it is an amplitude can take any value over a continuous range. I'm taking the continuous range of the signal. So an analog signal, amplitude can take any value over a continuous range. What is a digital signal? Amplitude can take only a discrete finite values of there. Only the discrete values of there. 1, 0, 1, 0 like this. So digital signal amplitude can take only discrete values are there. So changing analog to digital signal, how we are changing from analog to digital or analog ADC, like ADC. So analog to digital conversion, it is a continuous signal. So the x-axis is a time and y-axis I am taking as an amplitude. So with respect to time and amplitude, I am taking an analog signal, that is a continuous signal. And here, when I am going to the figure B, it is a I am going to the figure B. So what is happening here? So these continuous signals, this continuous I am taking, number of samples are there, time signals. So total T is there. I'm taking as a samples. So 0 to T, 2T, 3T, 4T, 5T. So I am converting to the samples of the time with respect to time. That is a sampling time. Okay, and it is an amplitude. I will not change the amplitude, but with respect to amplitude, I am changing the time levels. So that is a sampling time. So how many time levels are there? I am taking here 5T. So T, 2T, 3T, 4T, 5T, 6T, like this. So I am converting to the time levels. So after this one, I am taking as a number of samples are there. So each amplitude level, the amplitude is here increasing or not? Yes, I am increasing. Here I am decreasing. So increasing to decreasing order. This in this order, increasing to decreasing order. What are the samples are there with respect to amplitude? So with respect to amplitude, I am taking the samples. How I am getting the samples means with respect to sampling time, I am taking the number of samples are there. Here I am taking 1, 3, 5, 6, 4. So how many samples are there here means 4 samples are there here. Here 4 are there. Here 6, 5, 3, 1, 1 like this. So from this amplitude with respect to time. So what are the men? The 3 steps of the digitization of a signal, sampling of the signal. First one is the sampling, quantization of the amplitude, and a binary encoding. So with respect to sampling process, here sampling and quantization, then it is converting to the binary. So with respect to the amplitude, I'm converting with the help of sampling and quantization method. I'm converting to the binary. So in this binary code, what is a binary code means 1001110 so on like this. So I'm taking as a binary code. So here amplitude is very high. So that is I'm taking the width is very high 100110101. Here the width is very high. So 110 like this. So analog signal is converting to the digital form. So this is the input and it is the output. It is the analog signal. It is the digital signal. So it is the analog and the final one is a coding. I'm calling as it is a digital signal. Why I'm calling it is a digital signal means it is in the form of binary. So that is the reason I'm calling it is a digital signal with respect to coding. So what is the first stage? Analog signal, sampling, quantization, then output is a coding of binary code, that is a digital signal. So in the sampling and quantization, one can convert an analog signal to a digital signal by sampling and quantization, collectively called analog to digital conversion. So analog to digital conversion, ADC. The process of the signals are then converted back into the analog to signal using reconstruction or interpolation operation called digital to analog conversion or DAC. Analog to digital, DAC means digital to analog. So analog to digital and digital to analog conversion. So analog to digital, sampling and quantization. Digital analog means quantization and sampling, reverse order. So it is in the sampling and quantization, it is possible of analog to digital conversion and digital to analog conversion. The process of the signals are then converted back into analog to digital using a reconstruction of interpolation operation called digital to analog or DAC. So what is ADC means? One can convert analog to digital by using sampling and quantization, collectively called analog to digital conversion. So here ADC and DAC conversions are possible. So what is the sampling process? The sampling process is a basic operation in the digital communication. In this process, the continuous time analog signal is sampled by measuring its amplitude as a discrete instance. So the continuous time signal is converted into a corresponding sequences of the samples that are usually spaced uniformly in time. It is necessary to choose the sampling rate properly, so the sequence of samples uniquely defines the original analog signal. So in the sampling process, what is happening? The sampling process is a basic operation in the digital communication. It is a basic operation in the digital communication, that is in the ADC or in the DAC. In this process, the continuous time means analog signals into a converting to the samples by measuring its amplitude, and it's a discrete instance. So this sampling measuring it into the amplitude of discrete instance. Discrete means converting to the digital. And the continuous time analog signals, always continuous are called analog signals, is converting into a corresponding sequence of samples that are usually spaced uniformly in time. Already we choose that. I am taking as a T and V means amplitude. So it is a continuous signals. So the continuous signals with respect to time and amplitude, I am converting to the sampling and quantization. It is necessary to choose the sampling rate properly, so the sequence of samples uniquely defines the original analog signal. So what is the original analog signal? So the with respect to time and amplitude, what I am preferring to take the continuous signal, that is called the original analog signal. So sample. To sampling a continuous time signal x of t is to represent x of t at a discrete number of points t equal to nts, where ts is a sampled period. So what is our t means? T T, 2T, 3T, 4T, 5T, like this. So what is the total means? What is the T function means? X of T with respect to x-axis. The sampling in a continuous time signal x of t is to be represent x of t at a discrete number of points, that is t equal to n into ts. N means number of samples. Number of samples into ts. Suppose ts means total. How many are there? T, 2t, 3t, 4t, 5t. So how many are there? Number of means n equal to 5 ts. So total how many are there? 5 into ts, number of ts. So t equal to 5 ts or t equal to 4 ts, like this. So it is the sampling period. What is the sampling period means? T equal to 4 ts or t equal to 5 ts. The formula equal to t equal to n ts. So see here, you can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many are there? 13 samples I am taking here. 13 samples. So each sample I am taking ts. So between the ts. Total s of t equal to si. Like this. So sampling period. What is the sampling period means? Between this one and this one. That is a sampling period ts. So what is the sampling theorem? The sampling theorem states that a band limited signal x of t with a bandwidth w, w is the highest frequency, can be reconstructed from its sample values if the sampling rate frequency fs equal to 1 by ts is greater than or equal to the twice the bandwidth w of x of t. The minimum sampling rate fs of an analog band limited signal is called Nyquist rate. So what is the sampling theorem? The sampling theorem states that a band limited signal x of t, with a bandwidth, what is a bandwidth means I am taking as a w, is the highest frequency, then it can be constructed from samples of the values. Samples of means I am taking previously, suppose nts. Here how many are there? nts. How many samples means nts. Small t equal to nts. So it will be constructed from the sample values. How many sample values are there? Suppose I am taking 5 samples or 13 sample values. So sampling rate. What is the sampling rate means? It is a frequency. Fs equal to, what is the sampling rate means? Fs equal to 1 by ts. So here already we know that now what is the ts. So ts equal to t by n, like this. Okay. So Fs equal to 1 by ts is greater than or equal to the bandwidth w. So Fs equal to 1 by ts is greater than or equal twice the bandwidth of that one. So that is a formula. Fs equal to 1 by ts equal to 2w. That is Fs equal to Fs greater than 2w or 1 by ts is greater than 2w. Okay. So the minimum sampling rate of Fs for an analog band limited signal is called Nyquist rate. So, and another one of the sampling is that as long as a sampling of the analog signal is taken with a sufficiently high frequency, higher than the minimum Nyquist rate of twice the signal latest frequency, it can be shown that there is no loss in information as a result of taking discrete samples. So, what is the continuous data? No loss at discrete. No loss at discrete levels. So as long as the sampling of the analog signal is taken, analog signal means continuous data, with the sufficient high frequency, higher than the minimum Nyquist rate of twice the signal rate, largest frequency, it can be shown that there is no loss in information as a result of taking discrete samples of that one. Okay, continuous are taking to the discrete samples. And what is a quantization? In order to process the sampled signal digitally, the sample values have to be quantized to a finite number of levels, and each value can then be represented by a string of bits. To quantize a sample value is to round it to the nearest point among a finite set of permissible values. There is a distortion will inevitably occur. This is called quantization noise. So, in combination of the process of sampling and quantization, the specification of the continuous time analog signal becomes into the limited to a discrete time. Okay. So continuous are converting to the digital. continuous or converting to the digital. In this representation, each of this discrete set of values as a called encoding process. The code consists of a number of code elements are called symbols. So I am converting to the binary or not? Yes, I am converting to the binary. So each binary code consists of set of symbols, and this binary coding, the symbol take one of the distinct values. It tendency coding the symbol may be one of three distinct values, and so on for the other codes. So each zone is assigned a binary code. The binary code consists of bits. So how many bits are there? Suppose I am taking 8 bit or 16 bit. How can I means 10, 10, 10, 10 like this. So the number of bits required to encode the zones or the number of bits per sample is obtained as the following: NB equal to log L base 2. Given the for example NB base 3. The 8 zone level codes are there 000, 001 like this. So n bit means 2 cube equal to 8. So 3 bits are possible. So assigning codes to zones, 000 will be referred to zone minus 20 to minus 15. 001 is a zone minus 15 to minus 10, etc. So it is considering the analog signal. I am taking analog signal with x-axis is time, y-axis is amplitude. So this I am converting to the samples. First sampling, it is one sample. So how many samples are there means x of x n ts. N and the number of samples are there in the ts with respect to time. Here the dividing the range into 4 zones. 1, 2, 3, 4. I'm dividing as 4 zones. So what are the 4 zones means? 2, 4, 6, 8, 10 like this. I'm taking zones. So assigning the quantization levels to the 0 to 3 of the middle of the each. So I'm taking the 4 zones means 0 to 3. 0 to 3. So total 4 zones are there. I'm converting to the zones. So 2, 4, 6, 8, 10 are the levels, and 0, 1, 2, 3 are the zones. So it is an amplitude with the number of samples. So how many samples are there? Total how many samples? I am converting to the zones. 4 zones means 0, 1, 2, 3. Here, approximating the values of the samples, amplitude can be the quantization values. So what are the quantization values are there? So the samples are converting to the quantization levels. How many zones are means 0, 1, 2, 3 zones are there. Approximating the value of the sample amplitude can be quantization levels. Each zone is assigned to the binary code. So total 4 zones are there. 0 to 3, that is 0, 0, 0, 1, 1, 0, 1, 1. Total 4 zones with 4 levels are there. Each zone is assigned a binary code. So what is a binary code means 0, 0, 0, 1, 1, 0, 1, 1. Total 4. 4 are applied. Approximate the value of the samples applied out of quantization values. So it is the sequence of the bits of the samples. It is I'm taking some 8-bit example or 16-bit. So how many zones are there? Total 4 zones. 0, 0, 0, 1, 1, 0, 1, 1. Total 4 zones are there. So 4 zones means 4 levels are there. At the amplitude 4 zones. At the x-axis with respect to time 0, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 0, 0, 0. These are the levels. So I am taking these levels in the form of binary levels. So these binary levels 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 0, 1 like this. So how many samples? 1, 2, 3, 4, 5, 6, 7. So total these 7 samples I am converting to the binary, and y-axis the amplitude I am taking as a zones. So 0, 0, 0, 1, 1, 1, 1, 0, 1, 1 are the 4 zones of the amplitude. So f of x comma y is the input analog image, analog input, that is f of x comma y. I'm converting to the samples. Okay, what are the sampling output is fs of x comma y. S means sampled output. I am converting quantization. So this quantization fs of x comma y is the input, and what is the quantization? UM is a quantized output is there. So I'm taking into the computer as the output. I'm showing in this computer the digital image is showing in the computer. So the digital image. So what is the input? Analog input or analog image. Analog image sampling. What is the sample input? Analog image is a sampled, and fs of x comma y. S means number of samples are there. So sampled output means fs of x comma y. So what is the quantization? So from the sampled output, that is fs of x comma y is the input for the quantization. What are the quantized output means u of m comma n. So that means partitions. Number of partitions are there. That is the quantization, quantized levels. So when it is showing in the computer, that is a digital image, it is showing in the computer. So in the computer, what is this one? Digital image. It is the input of the computer. U of m comma n. What is happening here? So u of m comma n means digitization. Here the digitization is going on, quantization. So that is an analog display, and it is a display. Here what is showing on DTA conversion means, here what is output means? So the digital image is the input of this computer. Again, the digital image is converting to the digital to analog conversion with quantization and sampling process. The display is the analog image is showing. So it is the image sampling and quantization. That is the analog image display. So it is a one real-time example, sampling in the two-dimensional space, basics of image sampling. So it is the original image, input image, and it is a sampled. It is a sampling output. So the original image with respect to the sampling output. Number of samples I am taking here. Number of samples are there. So it is the image with respect to the samples. Here image sampling equal to the original spatially continuous brightness function f of x comma y. Only the black dozen positions. Only where the grid allows. Okay, it is a Nyquist rate. Already we discussed what is a Nyquist rate. The aliasing effect of the fold over frequencies. It is the aliasing fold over frequencies. It is a sampling theorem in the two-dimensional case. So it is another one. Sampling and quantization. It is an interpolation filter or a display of the system spectrum. It is the input of the signal. So this I am converting to the interpolation of the error. Practical limitations in image sampling and reconstruction. So is there any noise is occurred? So it will be showing in the noise. If noise will be occurred, it is showing. Okay. When it is in the Nyquist rate, it is showing this one. It is another one. The continuous image project in the sensor array, result of the image quantization. It is the original image. It is the original result of the image sampling and quantization. So it is the original image and converting to the samples. Converting to the samples. So these are the sampling and quantization. So these are the basic we have discussed. That is, what are the two types are there means sampling and quantization. Sampling and quantization are two steps in the image processing. So how we are converting to sampling and quantization, analog to digital and digital to analog conversion. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.